Welcome back, everyone. So next session is going to be how to run AI workloads on K3s cluster. It's going to be presented by Emrah from Prussia Research. It's yours.
Good day, everyone. I was going to say good morning, then it occurred to me that it's going to be noon soon. You might be getting hungry. I think there will be some break in an hour or so. Don't worry, next 30, 35 minutes, I will be the talking. And I'm going to cover basic concepts. Actually, I would like to start with one question. What is programming? Well, technically speaking, programming is giving a set of instructions to the computer machine tell to how to solve a task. So here we are defining every single step explicitly. So then what machine learning is? The machine learning, well, here, on contrary to traditional programming, we are not defining all the steps explicitly. On contrary, what we are doing, we are actually giving some data along with the output and expecting the computer to machine give us a program, which we call actually model. And later on, what we will do, we will give another data with a similar structure and then expect output. So, and how actually machine learning can do that? Well, machine learning is doing it using an algorithm or algorithms. And these algorithms actually are not anything new. And if you just look at a little bit the development in the AI field, that we will see even in 1950s, the key nearest neighbor was already there, so developed actually that year. And regression, for instance, is not anything new at all. It's used in the statistics. So then, why AI is booming now? Well, if we rewind the clock, go back in time, and look at how we used to deploy things, and come back today, look at the existing infrastructure, then we will see some significant change. In time, we become able to deploy large amount of data and process it. So basically, we have almost unlimited storage capacity and the process power, which help us to train better models. But that's not all. Time to time, in every single field, there is a revelation. There is something happens, which happened in AI field as well, that a transformer was introduced. This is usually used in deep learning. If I'm not mistaken, it should be natural language processing. It brought two innovations, big innovation, and it kind of changed the scope of the AI. So speaking of the processing unit, for instance, that the power we have, we can actually, these are not all, there are more units out there. I try to simplify. There could be one or two that you may know, you may not be see here, but my goal is here kind of show you, more or less the existing processing units. And we can actually categorize them under three distinct sections. For instance, general purpose. Well, we all know, right? CPU. We are using to solve daily basis tasks, such as this one, for example, I am presenting. And we can also have a CPU kind of categorized under different sections based on their instruction sets. And x60, x86, and the ARM is quite the one we are familiar, and RISC are also getting familiar. And the GPU, well, basically we use for the play games. But why? Because we need, why we don't use CPU? A GPU is meant for the rendering, because there's a large amount of mathematical computation is required. That's why we use GPU. And in these days, there are specific GPUs for deep learning as well. So now we are entering a specialized area where we have TPUs. This is the one, the image you see is Coral Edge from Google. And it is quite simple, single board computer. And it can actually be used for image classification or object detection. And DPUs, well, these are basically kind of helper. They are actually taking some of the workload from CPU and do it in much secure and more efficient way. And the quantum computers, well, this is a new era for all of us, right? Now we are having more than 1,000 qubits. And mainly quantum computers is used for complex simulations, like if you want to do something with less molecules, and also cryptography. Well, I'm going to skip these two. So we have been talking about, yes, AI, workloads, AI, and how we can run it, processing units. So the question, though, what we're going to do with this? Like, we have the model. So our goal is not only training them, but being able to actually use them. So can we run these AI models on local, for instance? The answer will be yes. There is a very simple Python script that will load the model and then use the predict. But if we can run models on local, can we run them on virtual machines? Well, answer will be yes. And if we can do it on virtual machines, can we run on containers? Yes. And now, if we can run on containers, if you already virtualize this model in an application on a container, will it be possible to run cluster? For sure. But then what cluster is? So basically, clusters are interconnected computers. In other words, they are joined machines, work together to support applications. What type of applications? Well, best example I can give you is the databases. Sometimes, not sometimes actually, you don't even realize that when you are using an application, whether you are reading data from another data source, or another, like a host, or another node, where the database is actually running there as a replica. Because one of the replicas, for example, might be crashed for some reason. Engineers might be doing something on that, like I did on my home lab 2 days ago, and I successfully crashed it. So you don't see actually something is happening over there. You are just getting still information. So basically, all machines are working together to support that application, and database is one of the example I can give it to you. And how we can actually create clusters. So one example will be, and one tool we can use is the K3s, K8s, Kubernetes. So it is actually well known. When I say well known, I mean it is like an industry standard, and it is kind of commonly used, but still it's kind of complex. It's easily, you can start with easily, but more you use, more you realize how much less you know. But it is a nice tool. I like to work with it as well, and I'm using on my home lab too. So it is actually kind of specialized way of creating a cluster. Mainly you are using it to run containerized applications. But Kubernetes, K8s in another way, it's for general purpose. And what if you want to run Kubernetes on ARM-based devices, like maybe at edge, maybe you want to do IoT? In that case, you can go another distribution called K3s. So this is a lightweight Kubernetes cluster, and you can basically run this on ARM-based devices. But how this actually cluster run a workload, or how we can run workloads on cluster? We can understand maybe now, we know now how we can create a cluster using different distributions of Kubernetes, but I think it will be better for me to talk about a little bit virtualization as well. So we have physical hardware at the bottom, right? And this could be even your local environment too. And there we are having the processing units like CPU or TPU or GPU, along with memory and the network card. Top of that, we have operation system. So we might run various different operation systems on the physical hardware. Could be Debian, could be, let's say, Arch Linux. And if we want to do virtualization, we may actually install applications like VirtualBox, VMware Fusion, or UTM. UTM is actually runs on Mac, and if you want to start the virtualization, do virtualization on Mac, like easy way, I will recommend you. It's easy to install, and it kind of seems doing good job. Also, VMware Fusion, now it's for free. You can also download it, and I think VirtualBox has always been free. So we can use these applications to virtualize on existing operation system. But there is another way to do that. The other way is actually not installing an operation system, but installing a hypervisor like Proxmox, for instance. So Proxmox basically accesses the underlying hardware directly. Applications like VirtualBox, for instance, they access the underlying hardware through the operation system. So on Proxmox, we can also create virtual machines as well as the containers. So if you want to create maybe a simple job, which will take maybe not that long to complete, you can actually create virtual machine using an automation tool. You can create a, let's say, a container using an automation tool, and then it will be, it will work, and then it will be terminated, for instance, and removed from the Proxmox. So I would like to look a little bit actually these applications things and kind of categorize them. So there are two actually hypervisors. Here we talk about the applications that you install on an operation system and or Proxmox. So they are actually called hypervisors, and there are two type hypervisors. One is type 1, which you install the bare metal. And one is, other one's type 2. It's also known hosted one. You install on existing operation system. Actually, there is a joke I like to, bare metal is the hardware itself. It's not like a rock band. So I would like to focus on type 1 hypervisors. And there are two I'm familiar with. There are two I run actually on ARM-based devices. One of them was VMware ESXi, which is gone now. Unfortunately, we are not able to download it. It was really nice. It has a really nice community, and people were writing custom scripts or even like drivers to run it on Raspberry Pi. It was running there for free, but now we are no longer able to install it. But Proxmox, on the other hand, can be installed on ARM-based devices in two different ways. One is Pimax. So I do not know now whether it supports latest version, Proxmox 8.17, but maybe you can upgrade it after you installed it. I haven't looked at. I focused on actually installing Proxmox as type 1 hypervisor on the Raspberry Pi directly. And I will go through each step and tell you a little bit more and also give you some tips. So it's actually quite straightforward, right? You need to start with the installation process. But let me tell you this one first. I am coming from a perspective that you have the Raspberry Pi, and you may have actually operation system installed over there, like the Raspberry Pi OS. Why? Because if you have the operation system installed, you can use the operation system to do some things. If you don't have it, don't worry. I will also some other slides to tell you how you can do it if you have the Raspberry Pi for the first time without any operation system on it. But if you have running the operation system, then you can basically install Raspberry Pi imager, or you can download it. I mean, you can install the imager using the package manager, or we can just download it. And after that, you can basically erase the SD card. And it must be SD card, not USB stick. For the first time when you are doing this, please be in mind, use an SD card. And after that, of course, everything will be wiped out, so be aware of that too. We are using the right SD card. So, again, you are on the Raspberry Pi OS, and what do? You update and upgrade the operation system, and you do full upgrade. I highlighted this one because it's kind of dangerous to do. It's not like should be your common practice you do all the time. But in this case, you can do it. And after that, you can install EEPROM package. You can RPA EEPROM via package manager, and then you can update it, and you can update the EEPROM. Why we do this? When we do this, now Raspberry Pi will be able to boot from USB. Because usually it just looks at the SD card, and that's all. Also, you can boot from the network as well. So after that, again, you're on the Raspberry Pi. You just need to run the Raspberry Pi config command, and then you access to, I'm not sure whether it is readable there. You need to go to Advanced Options, Boot Order, and select the USB. So what if you don't have the Raspberry Pi with an operation system on it and have another machine or something? Or what if you don't want to do any of these steps? So basically, you can actually use the Raspberry Pi imager on another machine, and you can choose to utilities images, and then choose the Raspberry Pi version. And after that, you can select the USB boot, and then you will have the USB card ready. So you may have you may not have any monitor to connect the USB Raspberry Pi, but if you put in the SD card, if you boot the Raspberry Pi, watch the lights. When you see green lights, it's blinking continuously. That means firmware is updated on the Raspberry Pi. Or you can just connect the monitor and see just a green screen. That means firmware is successfully updated. So this is what we are going to do here is required to access the BIOS, because we need to do two more things. So this script is a little bit actually over-engineered, so let me tell you what you will need to do. You just need to download the firmware and then copy all the files to same or another USB, but of course be sure that it's empty. And then download the UEFI firmware and copy all the files, the same USB, and there will be same files there, so you will overwrite them, and then delete all the files, start with kernel. So after that, you will reboot the Raspberry Pi, and now you will be able to access the BIOS. And as I said, we need to do two more things, and one of which is actually kind of funny. You need to actually disable the limitation for the RAM, because it comes with 3 GB limitation, and even though you have 8 GB, you won't be able to use the whole power. So first things, you need to do this one. And after that, so this might be a little confusing. We already actually choose the USB, right, to boot from. But You also need to tell the Raspberry Pi what USB port you need to boot from, because you need to use two USB ports. One is for the installation and the second one for the storage. And you need to come to boot manager and specifically choose what USB you want Raspberry Pi to boot from. After that, you can actually download the Proxmox ISO, and the recent version I know, latest version I know is 8.1.7. And be aware you need to download the ARM version. And after that, you can use, if you're on Linux, you can use command line, or you can just use Balancer to burn the ISO in a flash disk. So actually, you can do these steps maybe before and after, but when you reach here, now you have the UEFI SD card, you have already selected the USB to boot from, and remember, for now, we have some limitation. You won't be able to use Wi-Fi, so that's why you must internet cable connected, and you must have another storage connected as well, because Proxmox right away, when you see it, it will tell it cannot install. It will tell you this one. If there is no another storage, it can see, or if there is no internet connection. So, little tip, when installation is done, it will reboot, right? But because we have already chosen the USB boot and choose the installation disk, it will boot from that too, and then you will see Proxmox installation again. It's easy. When you see this screen, just click escape, get the BIOS again, and then change the order, boot order. In fact, you don't need to even use the USB stick anymore where you have installation files. You can just target the storage one where the Proxmox has been installed. So, as soon as you access the dashboard, you might need to actually update the repositories because you're going to use this for free and you need to get updates. That's why you need to actually change the sources a little bit, but I will recommend you to just use the dashboard, and also this will be the first time you start using maybe the Proxmox you will get familiar with. You just need to use the no subscription one, and that will be all. You will get updates. So, there is one thing I would like to share with you guys. Proxmox has already a community, and there are lots of scripts out there. And you can actually access these websites, Proxmox scripts or helper scripts. So you just go through, and if you want to spend some time just going crazy with this, I am doing it. And you can actually learn more about not only the Proxmox, also what scripts out there and automation as well. One of which, for example, Home Assistance. And there is already a script for that you can install, you can get from there. It's just one line command. You will copy and paste the terminal on Proxmox, and you will install Home Assistance specifically on Proxmox on Raspberry Pi, or let's say ARM-based devices. In fact, if you look at the script, you will see how to create Home Assistant scripts. You will see how you create virtual machines on Proxmox. So here, I am using Debian No Cloud. If you are starting for the first time, and if you don't know what Linux distribution you should use, I will suggest you to use Debian, because it is to me, it is easy to start with, especially if you have the Raspberry Pi. There is a Raspberry Pi iOS may be installed, which is Debian version. So you are not going to actually, basically you are just enhancing the distribution a little bit, let's say. So upgrading a little bit. And then you can get familiar with the networking on Debian. You can understand how the Linux works, the containers, and later on you can move another specific Linux distribution if you think you have a reason, or just for fun, why not? And a couple tips. OS type is L26. It indicates the Linux. And I use SCSI single because it is the best practice. And BIOS type is OVMF. And here, two things more. Install guest agent. That will not work. For now, it's not working on ARM-based devices, or maybe on just Raspberry Pi. But I highlighted it because you can actually use it on x86 if you have it. And be aware that when you run command to add user, so now that user will be exist on the image file. So if you use it next time, if you run the script again, then you will get an error message because that user already been created, and you can use it again and again actually. And no cloud has no root password, so I am just adding my own root password. And this is the whole script how it looks like. And again, there is a small issue. We are not able to use actually cloud in it, unfortunately, which I really wanted to do. But maybe there is a bug. It will be fixed later. When you use IDE 2, for instance, and when you run the virtual machine, it says it cannot find IDE 1. So I am still figured out whether there is a solution for that. But this might work on, again, if you have a Proxmox on x86 machines. But this is not that sustainable, by the way, if you want to create this again and again and again. I mean, you can write a bash script, but it is not healthy. So let's get some tofu. As you may know, it's an open source project, and it actually can be used with Proxmox providers. There are 2 Proxmox providers I recommend to work with. Basically, what you can do, you can actually create a template, and after that, you can actually use one of these providers, clone it. So you can clone, for example, 8 machines, 8 times, and 3 will be for the control planes, and 5 will be for the agents, for instance. And after that, you can access those machines via SSH using an Ansible, and you can install the necessary scripts to run a Kubernetes cluster. And speaking of the scripts, so installing K3s is very straightforward. You just need one line of code, and that will be all. But if you want to, create a highly available cluster, you can actually put a little bit more arguments. You can actually put different flags. I actually put there one, not label. I am going to explain a little bit more detail why I have done this. So as you can see, I am running one script on the control plane, on the host, that will be a control plane, and then that's it. It will be a control plane. And then I am getting the token, which is already generated, and then use this token to join that control plane, and then now we will have a one control plane, one agent cluster. But this is not what I want. I want actually high availability cluster. What I do, in the beginning, I just create etcd. So it will be just the etcd, and there will be no any scheduling. So I am disabling all other components, such as disable scheduler and API server. So if you have this installed, you won't be able to use kubectl, because I am at the bottom you see actually kubeconfig. I highlighted it. I actually don't use it because I don't want to access this machine and then access the cluster from that machine. I just want to be sure that etcd just up and running there. So I put it there, but I don't use it actually, and recommend you not to do that. Just you can check whether etcd is installed just using it is a service. So systemctl status K3s, and then you will see whether the service is up and running. So here bind address is the address of that machine. And now control plane. So K3s URL, the first line, I am actually using the etcd IP address here. That's the etcd IP address. But if you look at the TSL, that is not the same IP address. This is the that is the load balancers or your proxy's IP address. So basically what will happen, later when agent want to connect or join this cluster, they are going to actually join via the load balancer IP address. So they will not know any control balance IP address. But control balance IP addresses must be maybe static or dynamic, but at least load balancers should know them. Then it will actually direct the traffic to control planes. So we already actually want to configure this, and we already disabled traffic, and we already disabled service load balancer. Instead, we're going to use metal-LB. So basically, you can create a namespace in advance. I do this because I want to have custom labels, which is kind of recommended, especially if you are looking for working with the post-security admission. And then you can, of course, you must have Helm installed. You can add the package, let's say, and then you install, actually you upgrade with install flag. Why I do like this way? I tried the other ways, the easiest way is just install, it didn't work. And after doing a little bit of research, it turned out that I need to wait for a validation failure policy. I need to ignore that. And basically, otherwise, when you run it, you will get error message that metal-LB cannot connect to the webhooks. So maybe it is just for the ARM-based devices. Maybe it will work differently on x86, but this is kind of the way I tried, and it worked. And you can also check the services later on. And the traffic, of course, after that, we will install. And there is, again, some configuration over there. I am actually upgrading with install flag. And one more thing, when you use Helm, when you are upgrading with install flag, I guess the Helm creates some instances. And if you install all the time, you create, I guess, new instance. And if you use upgrade with install flag, it upgrades the existing one. So you will have the same instance, I guess, about the versioning. So now we will have last part, kind of. We have 5 minutes to go, or? Okay. 25 minutes we left already, 5 minutes to go. Okay, so let's say you want to add new node. So you can add 2 more nodes, right? Or any number of nodes you want. But here I want to show you how you can add actually a node as a Raspberry Pi or the Jetson Nano, where we're going to do AI workload running. So if you want to add Raspberry Pi as a node, there is a simple simple Ansible scripts over here. So the reason I am showing you this, if you want to run Kubernetes on Raspberry Pi, like you want to install the K3s directly there, that's possible. After all, it is Linux. You need to do some little bit configuration. You need to basically enable the C groups. Otherwise, K3s will not work. And this is a simple Ansible scripts. We'll do it for you. I mean, it's just the simple scripts. You can access the boot command line text on the operation system as well. But if you like to automate things, this could be one way to do that. So the difference is when you want to work with not Jetson Nano, first of all, you need to install the K3s first. So here, on Raspberry Pi, you are not installing the K3s first. You are actually running the script, you do the change, and then you install the K3s. Here, you must install the K3s first, because then you will detect whether K3s actually has automatically configure the containerd. And in other words, you need to see whether K3s detected the NVIDIA runtimes. And you need to just check these 3-4 lines. And after that, you need to also make the NVIDIA runtime as default. So how we can do that? The best practice is do not do anything in the containerd configuration file. Just copy it with like some prefix, suffix, and then you can just change the default runtime to NVIDIA. After that, restart the containerd, restart the K3s agent, and then check the status. So if everything went well, what we will do, we will test, of course, right? This is a very simple bash script. So basically, it's actually pull the image from the Docker Hub and then runs it. If this runs successfully, if the configuration is done properly, if the K3s detected everything, and then you will actually get basically an output tells pass, or you can check the logs and to see whether you are seeing actually this one. Pass. So this is the output actually. And you can do the same things using Kubernetes as well. We've installed it, right? This is the how we can run very basic, how we can create very basic path with the same image. And here, as you can see, I am pointing here. I guess you can see the cursor. The highlighted part is not selected, GPU CUDA. This is the label I actually have on the agent. And the reason is that when you run this path, it will be scheduled on that node, where actually we are having the CUDA. So Jetson Nano is our host or node, and then we are running this pod specifically there. And then when we actually check the logs of that pod, we will see some information, technical details, and after that we will see this result pass. This is the last message over there. So that's pretty much what it is. Thank you for listening, and if you have any questions, I have my coworkers over there. If I don't know, I will delegate them the questions.
Thank you. There are no questions. Are there any questions here in person? Let's give it 5 seconds, maybe. Ah, there is. Go ahead.
Was it worth the struggle?
So was it worth the struggle?
Yes. But I crashed in my home lab, so there is no demo. I'm sorry.
How much time did you spend on it?
Like a month, sleepless nights.
Thanks for the question. Any other question? If not, thank you very much for your presentation.